In this video, we're going to talk about 2.4 Objective 4, where we sketch graphs of functions involving infinite limits. Let's sketch a possible graph of a function f together with a vertical asymptote satisfying the following conditions on the interval from 0 to 6. Those are x values there. So we need a 0.20 on the graph since f of 2 is 0. F of 3 is undefined, so that could be a hole or it could be a vertical asymptote. We'll see which it is here with the limits. Limit as x approaches -4 of f of x is equal to -1. So again, that could be a hole or that could be a point on the graph. We'll have to see, but the limit does exist there. Limit as we approach 1 from the right is positive infinity. So I assume that that's going to be a vertical asymptote at x equals 1. Limit as x approaches 3 from both sides here is negative infinity. And limit as we approach 5 from the left is negative infinity. So there's asymptotic behavior there. So let's start with the asymptotes here. 5 from the left is negative infinity, so that gets rid of this option and this option. And let's see, 3 on both sides of 3, we're going to go to negative infinity. So that's got to be a here. So let's just confirm all these things. We have the point 2, 0 on the graph right there. That's 2, 0. We have 3 is undefined because of that vertical asymptote there. That's x equals 3. This is x equals 1. And this is x equals 5 for those asymptotes. We have, as I get close to 4, we are getting to -1. So that's this high point right here of that little region between the asymptotes there. As I approach 1 from the right, I'm going to positive infinity. So that's this piece of the graph. 3 from both sides goes to negative infinity. And 5 from the left goes to negative infinity. So that is a. All right, let's sketch a possible graph of the function g together with its vertical asymptote satisfying all of the following conditions. So we need g of 2 to be 1. So that looks like that's on all of them. G of 7 is equal to -1. And that appears to be okay with all of them. Limit of g of x as x approaches 6 is negative infinity. So we have to go to negative infinity on both sides of 6. So that would be not this one and not this one. This one would be okay, and that one would be okay so far. And as I get close to 8 from the left, I go to positive infinity. And 8 from the right, I go to negative infinity. So that's C, not D. C, so I'm going positive infinity from the left and negative infinity to the right. I went to negative infinity here on both sides. That asymptote, I have this point and this point that are given to us here. So everything is taken care of there. Let's go ahead now and look at number 3. Match each function with its graph without using a graphing utility. So x over x squared plus 1. It's going to have a horizontal asymptote at y equals 0 because degree of the denominator is greater than degree of the denominator is bigger than degree of the numerator. We have an x-intercept at 0, 0. And we have a y-intercept also at 0, 0. And what else here? We could use some derivatives if we wanted to find intervals over which it's increasing and decreasing. No vertical asymptotes. So because there's no vertical asymptotes, that automatically gets rid of all these options that have vertical asymptotes. And the only option left there is D. That's correct. X squared plus 1. If I try to set that equal to 0, x can't be equal to plus or minus I. In the real world, we're only dealing with a real axis and a real axis. So now I have vertical asymptotes at x equals -1 and x equals 1. I still have a horizontal asymptote at y equals 0 because degree of the top is less than degree of the bottom. Still have an x-intercept at 0, 0, and a y-intercept at 0, 0. See, now I have two vertical asymptotes, -1 and +1. So that's going to be one of these graphs here. And I need to have an x-intercept at 0, 0. So that's not that one. It's got to be this one. All right. With C, we're going to have no x-intercept. And we're going to have a y-intercept at 0, -1. We're going to have a horizontal asymptote at y equals 0. We're going to have vertical asymptotes at x equals -1 and x equals 1. So I'm sorry that questions get over top of graphs sometimes when there's a page break like this. Do my best here to show you it can't be this one, or this one, or this one, because it has to have two vertical asymptotes here. And there's no x-intercept this time, so it's not that one. It's going to be F. All these graphs were supposed to be up here at the bottom of this page. So now the equation here is going to be f of x is equal to x over x minus 1 quantity squared is what that says. And we're looking at these 6 pictures down here. Try and look at that. So I have an x-intercept of 0, 0 again, a y-intercept of 0, 0, have horizontal asymptote at y equals 0, vertical asymptote at x equals 1, and there's a multiplicity of 2 there, so it's going to do the same thing on both sides of the asymptote. So let's see, vertical asymptote at x equals 1. It's going to be one of these, does the same thing on both sides. It's good, has to go through 0, 0, so that's going to be B. Let's keep going here. We have 1 over x minus 1 squared. So x-intercept is none. Y-intercept here is going to be 0, 1. I square that -1 in the denominator. It's 1. 1 divided by 1 is 1. Horizontal asymptote here is y equals 0. Vertical asymptote is x equals 1. Again, multiplicity of 2 on that factor, so it's going to do the same thing on both sides. So we have x equals 1 for the vertical. Same thing on both sides. No x-intercept this time, so that has to be C. And I believe this is the last one for this question. Our x-intercept is again at 0, 0, which is also a y-intercept. And we have a vertical asymptote at, let's see, horizontal asymptote here is at y equals 1, because degree of the top, degree of the bottom are the same. X divided by x, there's going to be 1. Horizontal asymptote y equals 1. Vertical asymptote at x equals -1. Some things got cut off pretty bad, but you will see the correct answer up here in these first three. Sorry for that again. It's just the way that things happen when I print and stuff gets split between pages when it's close to a page break. So we're going to have vertical asymptote of -1 is going to be this one. And we have our x-intercept is supposed to be at 0, 0, and it's not. So let's draw what the graph should look like here. So we should be going through 0, 0. We should have a vertical asymptote at -1 here. And we should have a horizontal asymptote at y equals 1. And on the, as I get close to -1 from the right, this is going to be positive, and this is going to be negative. That's going to make me go to -infinity. As I get close from the left, this is going to be negative. This will also be negative, and I'll go to positive infinity. I'm interested if I ever equal my horizontal asymptote, and I do not. So that means that I'm going to come down this way and get close to but never cross that asymptote. And I'm going to come up this way and cross through and get close to my asymptote there, but never cross over it. And that is probably so they just shifted B up too much. They need to shift that they need to shift this piece down 1. So this point that's a 0, something that's not 0 is down here. This needs to be like this. It was supposed to be B for the correct answer, but they drew the graph wrong. So it needs to go through 0, 0, because when x is 0, y is 0, and the origin is right there, not there. So it's off by like a half. Okay. Find polynomials p and q such that f equals p over q is undefined at x equals 4 and x equals 5, but f has a vertical asymptote only at x equals 5. So that's going to be x minus 4 in the top, x minus 4 in the bottom, x minus 5 in the bottom, and that's going to give us p is equal to x minus 4, q is going to be equal to x squared minus 9x plus 20, or factored form. So that's going to be c. And then when we graph that, going to have asymptotes at only at 5 and it's going to switch directions there. It's not going to be an even power on that. So then we need to go through, it's not going to have an x-intercept. So it's not going to be D. And our 0 is at x equals 4. So that's an A. Because the hole is in the wrong place there. All right. Now sketch a graph for the function with the following properties: that as I come at 4 from the left, I go to positive infinity. As I come at 4 from the right, I also go to positive infinity. So that's got to be C. I don't even need to finish up the rest of these things. As I approach 0, I go to negative infinity, both sides there. As I approach 3 from the left here, I get close to 2. As I approach 3 from the right, I get close to 3. So there's this jump discontinuity, and f of 3 is 5. All right, that's it for this video, and we'll come back next time, and we'll talk about 2.4, Objective 5. See you for the next video.